Morning, everyone. In the last lectures, we have already discussed about, diode and the symbol of diode, its characteristic, signal diode, in which mode diode works, forward biasing mode, reverse biasing mode, and what are the VI characteristic of diode, what are signal diode, what are the rating of signal diodes, what are power diodes, what are the rating of power diodes. So, in this lecture, we will discuss about the switching characteristics of diode. So, before going on switching characteristic of diode and VI characteristic of diode, first we have to understand the you know the difference between VI characteristic and switching characteristics of the diode. Okay. So, if we talk about VI characteristic of the diode, it means that the characteristic which is drawn between voltage and current, that is your VI characteristic, and the characteristic in the VI characteristic we take the voltage across x-axis, and we take current on y-axis. When you talk about switching characteristics, switching means the diode turning on and off, so it is all about related to your time. Okay. So the switching characteristic is always drawn between voltage or time or current or time. So in this lecture, we will discuss about the switching characteristics of diode. So what are the course objective of this subject? That to introduce students to the basic theory of power semiconductor devices and passive components and their practical applications in power electronics, to familiarize the students to the principle of operation, design, and synthesis of different power conversion circuit and their applications, and to provide strong foundation for further study of power electronic circuits and systems. After this lecture, I'm expecting from the student that that student will be able to understand that what is diode, what are the basic characteristics of diode, and what are the switching characteristics of diode, and what are the importance of this switching characteristic, and why we are studying this switching characteristic of diode. Because it is very important to understand the switching characteristic of diode, because by the understanding the switching characteristic of diode, you can easily analysis that how diode works, and what is the power dissipation across the diode, and what are the behavior of holes and electrons, how it is swipe out when diode is turning off, and how holes and electrons flow when diode turned on, and what are the voltage and current which is appearing across the diode when diode is turned on and off. So these are the very important point which is very important to understand for understanding the behavior of diode. So let's talk about the some points, that is so this is a basic structure of diode. This is your diode. So electrical switches over mechanical switches, if we compare the electrical switches and mechanical switches, you can see that the mechanical switch is always having rotating part. And if a switch having rotating part, that it means it is having some frictions. Okay. And if it is having some friction, there will be some friction losses, and maintenance will be high. So if we compare electrical switches and mechanical switches, what we have to do, electrical switches are a preferred choice over mechanical switches due to the following reasons. So, mechanical switches are prone to oxidation of metals, whereas electrical switches don't. And mechanical switches have movable contacts. They are more prone to stress and strain than electrical switches. The warn and tone of mechanical switches often after they are working, and hence an electrical switches is more useful than mechanical switches, because mechanical switches always required large maintenance. And you can replace mechanical switches if possible by the electrical switches, because electrical switches is more useful and portable and higher efficiency. And there is no problem of oxidation in electrical switches, and it's not having any kind of a movable part, so there is no friction and other losses, right? Next is working of diode as a switch. If you talk about the diode and if you want to work diode as a switch, so there are few points we have to consider when diode is working as a switch. So whenever a specified voltage is exceeded, the diode resistance gets increased, so making the diode reverse biased and it acts as an open switch. Already we have discussed when diode is in forward biasing, it will behave like a closed switch, and diode when it is in a reverse biasing, then it will behave like a open switch. So whenever a specified voltage is exceeded, the diode resistance gets increased, making the diode reverse biased and it acts as an open switch. So whenever the voltage applied is below the reference voltage, the diode resistance gets decreased, making the diode forward biased and it acts as a closed switch. So the following circuit explain the diode acting as a switch. So if you want to if you want to use diode as a switch, then this is the basic circuit where you can see that we are connecting the diode. It is connected between two batteries. One is in forward biasing and another one is in reverse biasing, and we are taking two resistances to limit the current. So these are the resistances R1 and R2, and you can see that these are the resistances and R1 and R2. You can see that when diode is in forward biasing, it means when you connect this switch to this terminal to this terminal. So in this case, the diode is in forward direction and the current will start to flow. So that is your, forward biasing, and diode will behave like a switch which is turned on. Now, if you connect this diode to this terminal, then diode is connected to the negative terminal, and this negative terminal or cathode terminal, you can say, which is connected to the positive terminal. So diode is in the reverse biasing case, and diode will behave like a off switch. Okay. So this is a switching circuit which can be used for diode. Now, so a switching diode has a PN junction in which a P region is lightly doped and N region is heavily doped. So the above circuit symbolizes that the diode gets on when positive voltage forward bias the diode, and it gets off when negative voltage reverse biases the diode. Now ringing. So as the forward current flows till then with a sudden reverse voltage, the reverse current flows for an instant rather than getting switched off immediately. So the higher the leakage current, the greater the loss and the flow of reverse current when diode is in reverse biasing. Suddenly may sometimes create few oscillation, that is called a ringing. So this is very important point when diode is connected in the reverse biasing. What you see that as the forward current flows till then with a sudden reverse voltage, the reverse current will start to flow uh, and instance the it won't get off switched off immediately. So the leakage current will be high and the losses will be large. So the flow of reverse current when diode is reverse biased suddenly sometimes create oscillation which is called ringing. So this ringing condition is a loss and hence should be minimized. To do this, the switching times of the diode should be understood. So what is diode switching times? So because to avoid this problem ringing, okay, to avoid this problem ringing, when your diode is not turned off properly, okay, when you just uh, diode is conducting taking forward current and you suddenly switched off the diode, the diode is basically practically turned is not turned off. There is some leakage current which start to flow in the reverse direction and it can damage the diode, or there may be some sound which is called ringing, or there may be some oscillation which is called ringing. So there will be some losses. To avoid these losses, what we have to do, uh, we have to consider the switching time of the diode. Okay, and it must be understood. So what is diode switching time? So while changing the bias conditions, diode undergoes a transient response. The response of a system to any sudden change from an equilibrium position is called as transient response. Okay. So when you are changing biasing condition, means the diode is in forward biasing and you suddenly changing that forward biasing to reverse biasing, then the diode undergoes into the transient condition, and the response of a system to any sudden change from an equilibrium position is called as transient response. So the sudden change from forward to reverse and from reverses to forward bias affect the circuit, and the time taken to respond to such sudden changes is the important criteria to define the effectiveness of an electrical switch. So to avoid these oscillations, we have to um, analysis the switching time of the diode, and clearly we have to understand what are how much time it will take to turn off. After that time, you can turn on the diode. So the time taken before the diode recovers its steady state is called as recovery time. Recovery state means that when the diode is in forward biasing and you want to turn off the diode. So before that, the diode is getting turned off, the holes and electrons must be swiped away. So diode gets turned off. The time which is taking to recovery, that is called your recover time. Now the time interval taken by the diode to switch from reverse bias state to forward bias state is called as forward recovery time. Okay, when the time interval taken by the diode to switch from reverse bias state to forward bias state is called as forward recovery time, and that is denoted by TFR, forward recovery time. F is noted for here forward, R is for recovery, T for is your time. So this is your forward recovery time, which is represented by TFR. So the time interval taken by the diode to switching from reverse biasing to the forward biasing is called your TFR. So time interval taken by the diode to switch from forward bias state to reverse bias state is called reverse recovery time. Okay. Now, let's come to the next point. To understand this more clearly, let us try to analyze what happens once the voltage is applied to a switching PN diode. So, carrier concentration. Okay. Suppose your diode is uh, when you are applying some voltage across the diode. When P terminal is connected to the positive terminal of the diode and N terminal is connected to the negative terminal of the battery. So diode is in this case is in forward biasing mode, and now the voltage is applied to a switching PN diode. So what is happening? Carrier concentration. So to understand the switching characteristic of a diode, first we have to understand the carrier concentration. So what is carrier concentration? Carrier means the charge carrier. So charge carrier in a diode is hole and electrons. Okay. So if you talk about P-type, semiconductor, uh, it is heavily doped. Okay, it is heavily doped and by the trivalent impurity. So there is a deficiency of electrons. So there would be a large number of holes. So P is concentrated by a large number of holes, and N is concentrated by a large number of electrons. So what is happening? Basically, the minority charge carrier for P-type semiconductor is hole, and the minority carrier charge carrier for N-type semiconductor is holes. So what is happening? The minority charge carrier concentration reduces exponentially as seen away from the junction. And when the voltage is applied, due to the forward biased condition, the majority carriers of one side move towards the other. So they become minority carriers of the other side. So this concentration will be more at the junction. Okay. When you apply the voltage across the diode, so what is happening? the minority charge carriers are already swiped away, so there is a barrier. When you apply voltage, then the uh, because p-type semiconductor is connected to the positive terminal. So positive terminal will repel to the p-type semiconductor, so the hole will repel to the positive terminal. So hole will try to come into the n type of layer, and the n type of layer is connected to the negative terminal of the battery. So there is and negative, there will be a repulsion, so the electron will try to come into the p layer. Okay, hole is trying to going to the n layer, and electron is trying to come into the p layer. So there are majority charge carrier which start to move from one side to another. So and if holes are moving into the n layer, so in n layer the whole are your minority girl. Okay? So the this concentration will be more at the junction, right? You can understand with the diagram if it is given here. No. So the concentration will be more at the junction. So what we have to do that, for example, if n type concentration is, for example, if n-type is considered the excess of force um, that enter into n-type after applying forward biasing. So, there are some minority carrier hole which is already present over there in the n-type of material. So, let us consider few notations. So, the majority carriers in p-type is holes. I have already told you, which is denoted by PO. Okay, O means majority carriers, P type in which is hole. Now the majority carriers in N type is electrons, so this is represented by N. Okay. The minority carrier in P type electron is P, means hole. That's why this is represented. Actually, the capital P is representing, that is p type or n type, and the this is representing that this is hole or electron. So if we talk about that the p type layer, then the whole number of charge carrier in majority will be hole. So that's why this is represented by pp. And if you talk about this n type, capital N type, n type layer, so in which the electrons will be in a large concentration. And if you talk about the minority carrier in p type electrons, the uh, electrons will be, also the majority carrier in n type holes. This is equal to p and o. So during forward bias condition, the minority carriers are more near junction and less far away from the junction. So the graph below explains this. Okay. So if you check this graph, that this is your junction, this is your p-type layer, and this is your n-type layer. In p-type layer, the majority carriers are your holes, and the minority carriers are your electrons. If we talk about n-type semiconductor, in this layer, the majority carriers are electrons, and minority carriers are holes. So what is happening basically? If you apply voltage, so suppose this is in forward bias. In forward biasing condition, you have to connect the positive terminal of the battery to the p type and the negative terminal of the battery to the n type. When positive terminal of the battery when connected to the p type, it will repel to each other. When it repel to each other, then the hole will start to move from this side to this side. Okay, so the hole concentration will be more over here, because there are also some hole will repel these holes. So the hole will be stay here. And like this, the electrons will try to move from this n-type layer to p-type layer, because the n-type terminal is connected to the negative terminal of the battery. So what is happening? It will repel each other and electron will try to come into the p layer. So there are also some electrons which is in minority. So the concentration of electron will be nearest to the this junction layer. Fine. Now, excess magnetic carrier charges in p-type, Pn minus Pno, with Pno steady state value. And steady state means that when you are not applying any kind of voltage, and excess magnetic carrier charges in n-type. So this will be Np minus Npo, with Npo, which is your steady state value. So these are the excess magnetic carrier charge. Okay. Like if you talk about p layer, so magnetic carrier for this p layer will be electron, and this is your steady state value when you are not applying any kind of voltage. So the what is the excessivity of magnetic carrier in this? Then you can you can minus this Pn minus Pn, and like this the excessivity of magnetic carrier in n-type semiconductor is whole. So you can write Np minus Npo with Npo steady state value. So now during reverse bias conditions, majority carriers does not conduct the current through the junction. During reverse bias condition, majority carriers does not conduct the current through the junction and hence don't participate in current conduction. So the switching diode behaves as a short circuited for an instant in reverse direction, because there are some majority carriers hold for this, and for this these are electrons. So what is happening? This is your steady state, and the majority carrier does not conduct the current through the junction, and hence it would not participate in current conduction. So the switching diodes behave as a short circuited for an instance in reverse direction. So the minority carriers will cross the junction and conduct the current, which is called as reverse current. So the following graph represent the condition during reverse biasing. This is the condition during forward biasing. And charge current flowing, the current will start to increase. Okay, and the concentration of charge carrier nearest to the junction is large. Okay, this is the junction where the charge concentration of nearest the junction will be large. We talk about reverse biasing. Then the magnetic carrier will cross the junction, and because what is happening, because p-type semiconductor is connected to the negative terminal of the battery, so it will attract the holes, so they will try to come from this place to this place. Okay, like this n-type semiconductor is connected to your positive terminal, so electron will try to move from this place to this place. So the minority carrier will cross the junction and conduct the current, and this is called your leakage current, because the current which is flowing in the reverse condition due to your minority carriers. Okay, minority carrier for this your electron, and in this the hole. So the hole is trying to come from this place to this place, and hole is trying coming in this layer, and electron is going into this layer, because just because of this, the reverse current will start to flow. This is the minority carrier for this p-type, and hole is the minority carrier for it. Okay, so the minority carrier will carriers will cross the junction and conduct the current, which is called as reverse saturation current. So the following graph represent the condition during reverse biasing. So in the above figure, the dotted line represent equilibrium values, and solid lines represented actual value. These are the solid line which is representing your actual value, and this is your equilibrium current. Okay, So in the above figure, the dotted line represents equilibrium values and solid lines represent actual values. So as the current due to minority charge carrier is large enough to conduct, so the circuit will be on until this excess charge is removed, right? Suddenly when you diode is in off condition, so the charge carrier will start to flow in the reverse direction and it will conduct until this is not swiped away or not removed. Okay. So the time required for the diode to change from forward bias to reverse bias is called reverse recovery time. Okay. The time required for the diode to change from forward biasing mode to reverse biasing mode is called reverse recovery time because suddenly it won't get into the reverse recovery, reverse biasing at instantly. It will take some time. So the time which is taken by the diode from forward biasing to reverse biasing, that is called your reverse recovery time, and it is denoted by TRR. Okay. So when the diode is coming from reverse biasing to forward biasing condition, that is your forward recovery time. And when diode is coming from forward biasing condition to the reverse biasing condition, that is your reverse recovery time. So this is your reverse condition and it is coming into the forward condition. So the time which is taken from reverse biasing condition to the forward biasing condition to the reverse biasing condition, this is time t1, right? So this is your minority carriers and this is your steady state. So this is this is representing the minority carrier concentration. Now let's see this diagram where you can see that when it is coming from forward biasing mode to reverse recovery condition, that is your T1 time and this is your called your reverse recovery time. Now this reverse recovery time, there is some leakage current which is flowing. So this is your storage time. Again, this is going from reverse recovery condition to the off condition. That is your transition time. So the time which is taking from reverse condition to the off condition, that is your T3 minus T2. Okay. So once again, we can see that the time which is taken from forward biasing condition to come into the reverse biasing condition, that is your T1. When the time which is taken from reverse biasing condition to the forward biasing condition, that is your time T2. And when this is going from storage time, this reverse biasing condition to the time where is off condition, that is your time T3. So reverse recovery time TRR. So basically this is your reverse recovery time from T1 to T3. Okay. Now from the above figure, let us consider the diode current graph. At T1, the diode is suddenly brought to off state from on state. It is known as storage time, and storage time is the time required to remove the excess magnetic carrier charge. The negative current flowing from N to P type material is of a considerable amount during the storage time. So this negative current is equal to minus IR is equal to minus VR upon R. So the transition time is the time taken for the diode to get completely to open circuit condition after T3 diode will be in steady state reverse bias condition before T1 diode is under steady state forward bias condition. So the time taken to get completely to open circuit condition reverse recovery time is equal to storage time plus transition time. Already we have seen in the graph that this is your storage time when it is storing all the charges, then it is going from storage condition to the transition condition. So the total time which is you know called reverse recovery time is reverse recovery time is equal to storage time plus transition time. So where is go to get to on condition from off? It takes less time called as forward recovery time, and reverse recovery time is greater than forward recovery time. So a diode works as a better switch. Its recovery time is made less because see, if you are using diode as a switch and if you want high frequency switches, so what you have to do when you turned on the diode, after that you want to turn off. So suddenly, what we are expecting, uh, as we switched off the diode must be switched off completely. But there are some point we have already discussed that there are some magnetic carriers. They must be swiped away from the from junction to turn off the to turn off the diode. So if reverse recovery time is divided into storage time plus transition time, and this time must be less. Okay? So diode will works as a better switch if it reverse recovery time is less. So whereas to get to on condition from off, it takes less time called as forward recovery time, and reverse recovery time is greater than forward recovery time. So a diode works as a better switch if this reverse recovery time is made less. So what are the definitions? So definitions of no, of storage time, transition time, reverse recovery time, and forward recovery time is, let us just go through the definitions of the time periods discussed. Storage time. So the time period for which the diode remains in the conduction state even in the reverse bias state is called as storage time. So storage time, in the time of storage, the diode is in conduction mode, but it is in reverse biasing condition. So that is your storage time. So the time period for which the diode remains in the conduction state, even in the reverse bias state, that is your, means diode is in reverse biasing. Diode is in reverse biasing, but still it is conducting in the reverse direction. That's why this time is called your storage time. Transition time, the time elapsed in returning back to the state of non-conduction. That is what we are trying to do. We are trying to do the turn of the diode from on state to, we are bringing the diode from on state to off state. So this is a total time period, how much time it is taking to coming from on state to off state. So these parameters can be must be considered to analysis the switching of time of the diode. So transition time, this is the time where we have already seen in the graph, when storage, the time elapsed in returning back to the state of non-conduction, that is your steady state reverse bias, is called transition time. And reverse recovery time, the time required for the diode to change from forward bias to reverse bias, is called as reverse recovery time. Forward recovery time, the time required for the diode to change from reverse bias to the forward bias, is called as forward recovery time. So these are the 4 points which is very important to understand the switching characteristic of diode. That you first you have to understand that what is your reverse recovery time, sorry, forward recovery time, the time which is required for the diode to change from reverse bias to the forward bias, is called as forward recovery time, and the time required for the diode to change from forward biasing to the reverse biasing is called as reverse recovery time, and the transition time, the time elapsed in returning back to the state of non-conduction mode, that is your transition. So the factors which affects the diode switching time. So the factor which is affecting the diode switching time is, there are few factors that affect the diode switching time, such as diode capacitance, the diode resistance, doping concentration, depletion width, So the diode capacitance, the PN junction capacitance changes depending upon the bias condition. Diode resistance, the resistance offered by the diode to change its state. Doping concentration, the level of doping of the diode affects the diode switching times. Depletion width, the narrower the width of the depletion layer, the faster the switching will be. And a Zener diode has narrow depletion region that an avalanche diode, which makes the former a better switch. So these are the some applications which is used as a switching circuit of diode. High speed rectifying circuit, high speed switching circuits, RF receiver, general purpose applications, consumer applications, automotive applications, telecom applications, etc. So you can say that once we can revise what we have done in this lecture, that in this lecture we have done with the switching characteristic of the diode. So diode work in two modes. One is your forward biasing mode and another one is your reverse biasing mode. So in forward biasing mode, you have to connect the P type of semiconductor device to the positive terminal of the battery, and in N type semiconductor device, you have to connect the negative terminal of the battery to the N type semiconductor. Then it will be in reverse biasing. So suddenly, what is happening if you are using diode as a switch? What you have to do? First, you turn on the diode and turn off the diode. When you are turning on the diode, already diode was in off state or reverse biasing condition. So it will take some time to come from reverse biasing to the to come into the forward biasing condition. So there is some points which we have to consider, because suddenly it won't come into the forward biasing condition from reverse biasing condition. And like this, if you want to turn on the SCR, suppose diode is conducting and diode is turned on, and if you want to turn off the diode, then what is happening? That it will come from on state to off state, and there it will take some time. Okay, and the time which is required from coming from on state to reverse condition, then after reverse state to off condition, that is your reverse recovery time. So these are few points which must be considered, and the most important point, which is ringing. So what is happening when diode is in forward biasing and suddenly you turn off the diode immediately, and diode will not getting switched off immediately, because there are some leakage current which is flowing through the diode. So diode will start to oscillate. That is called your ringing condition. So first we have to understand what is the procedure which is required to turn on the diode, turn off the diode. And to for this, there are some few points which is very important. That is forward recovery time and reverse recovery time. So the time taken before the diode recovers its steady state is called as recovery time, and the time interval taken by the diode to switch from reverse biased state to forward biased state is called as forward recovery time. So the time interval taken by the diode to switch from forward bias to reverse biasing is called your reverse recovery. So these are the three most important points we have discussed in this lecture, and we must keep in mind when you are using diode as a switch. So main important thing, that this is the graph which you must remember, that how it is working when diode is coming from reverse state to forward state, and the majority carriers of whole of this p-type semiconductor is whole, which is start from moving from this place to this place, because it is connected to positive terminal. So positive terminal and p-type terminal will repel each other, and whole will try to come into from p-type layer to n-type layer, and the whole will concentrate it at the junction like this. When you apply voltage and the negative terminal is connected to n-type terminal, it will repel each other, and electrons will try to come into the p layer. So they are moving from a whole is moving into the n layer, electron is moving into the p layer. So movement of holes and electrons is your current in power electronics. So excess minority carrier, and for p type, what do you mean by excess minority? So excess minority carrier means that which is not recombining, in n-type semiconductor. Once hole and electrons recombine and become neutral. So there are some excess minority carrier in n-type semiconductor which don't recombine. And because of this minority carrier, the current will flow into the reverse direction. When diode comes into the reverse state, just because of these magnetic carrier, the leakage current will start to flow. And to come up with the diode from on state to off state, just before off state, first you have to remove all these minority carriers. And the time which is taken to remove these minority carriers, that is your reverse recovery time. Okay, which is divided into two parts. One is your, like this. See, one is your storage time. Okay, and next one is your transition time. So what is happening in the storage time? So at T1, the diode is suddenly brought to off state from on state. So it is known as storage time, and storage time is the time required to remove the excess magnetic carrier charges. So the negative current flowing from N to P. Okay, so type material of a concentration amount during the storage time. So this negative current is minus IR is equal to minus VR upon R. So transition time is the time taken for the diode to get completely to open circuit condition. After T3, diode will be in steady state reverse biasing condition. So before T1, diode is in under steady state forward bias condition. So the time taken to get completely to open circuit condition is reverse recovery time is equal to storage time plus transition time. So whereas to get the on condition from off, it takes less time called as forward recovery time, and reverse recovery time is greater than forward recovery time. So a diode works as a better switch if this reverse recovery time is made less. Okay. So if you reduce the reverse recovery time, the frequency of the diode will be high and you can use this diode for higher frequency applications. So this is the more important point, and the thing which you must remember, one is your reverse recovery time, okay, which is represented by TR, which is very important from coming in the diode from on state to off state. And the reverse recovery time will be less than the switching frequency of the diode will be high. Okay. So there are some few definitions which we have already studied. One, storage time. Storage time means the time period for which the diode remains in the conduction state. Okay, even in the reverse bias state is called your storage time, and transition time, the time elapsed in returning back to the state of non-conduction, and steady state reverse biasing is called transition time. And reverse recovery time, the time required for the diode to change from forward bias to the reverse bias is called reverse recovery time. Next is your forward recovery time, the time required for the diode to change from you know, reverse bias to the forward bias is called as forward. And so this is all about the switching characteristic of diode, and the switching of the diode, which depends upon these 4 points: diode capacitance, diode resistance, doping concentration, and depletion width. Okay. If we talk about Zener diode, so Zener diode has a depletion laser very narrow, so the avalanche breakdown is occur very fast. So this will perform a better switch. The narrower the width of the depletion layer, the faster switching will be. And the level of doping, how affects the level of doping, we will discuss in the next lecture, and how diode affects diode capacitance affect the switching of a diode, we will discuss in the next lecture. So these are the applications by which you can see that where you can use the diode as a switch. Now these are the references of this lecture where you can go and learn about the switching characteristic of diode. One is your Mohanad or Allen and William Robbins. This is Power Electronics and Converter Application and Design. I'm Rashid of Power Electronics, and Kaskian John G. Martin F. Sketch and George C. Burgess, Principle of Power Electronics, which is very good book. You can search in this book, Google or library, or you can purchase this book from ebook. So these are few questions by which would help you to understand what is diode, how much layer it is having, how much junction it is having, and it work how when it work in forward biasing. What are the voltage drop across the forward biasing? What are the voltage drop across in the reverse biasing when diode is connected into the reverse biasing? Which terminal is connected to which terminal? So these are few questions you must know, solve this question. So you would be able to understand that what is diode. So after this lecture, I am expecting from you that now you are able to understand what is diode, what is the VI characteristic, what are the switching characteristic, what is reverse recovery time, what is forward recovery time, what is storage time, and what is your transient time, and how can you improve the switching characteristic of the diode. Thank you.